Okay, in this video, we are going to find vertical asymptotes, and these are the three problems that we will solve together. But before we solve them, it's important to understand, what is a vertical asymptote. And in short, a vertical asymptote is when the x value makes the denominator 0. And so in this case, this is our rational function, and our denominator is x plus 1 times x minus 1. And in order to make the denominator 0, it will occur when x is equal to negative 1 and x is equal to positive 1. Because if x is equal to negative 1, we get negative 1 plus 1 is 0, and 0 times any number is 0. Likewise, if x is positive 1, 1 minus 1 is 0, and 0 times any number is 0. And we can visually see what is a vertical asymptote. So when x is equal to negative 1, we get this dotted line like this. And you see this red line, our graph, is getting closer and closer to it, but it never touches. And one of the reasons why is that when x is negative 1, you'd get something divided by 0, and you can't divide by 0. And same idea for this positive one. It gets closer and closer, but it never touches because at x is equal to 1, you get something in the numerator divided by 0, and you can't divide by 0. So what we're going to do is focus on this denominator here. We want to know what value of x makes it 0. So we can say x minus 3 is equal to 0. We can add 3 on both sides. And we will have a vertical asymptote at x is equal to positive 3. Now we'll have another problem here. The denominator cannot get to 0 because we have x squared plus 5 is equal to 0. And if you subtract 5 on both sides, we get x squared is equal to negative 5, and that can never occur. So the vertical asymptote would be none. Actually, we're going to do one more problem after this one because I want to mention an important property. But this one, same idea. How do we make the denominator 0? If x is equal to 2, we get 0. And if x is equal to negative 1, we get 0. So these are our vertical asymptote. So we're going to do one more problem. Okay, this is going to be our last problem, and the reason I added this is that there's something special that we need to consider. If the numerator is x plus 1 times x plus 2 and the denominator is x plus 1 times x minus 3, we see something that's common between the two. So before we check the denominator, you have to cancel what is the same, and so we're going to cancel this piece and this piece. So we don't even consider this piece. This piece will not lead us to a vertical asymptote. It's going to lead us to something called a hole. And now we focus on the vertical asymptote, so now we focus on this piece. So what value of x makes this piece 0? And the value would be x is equal to 3. And that's how we can find vertical asymptotes.